Okay, so following with these topics, today's topic, which is human-robot interaction, I will talk today. I'm Anaís Garrell. I'm a lecturer professor here at UPC, and I basically study how robots should interact with humans in different tasks. Okay, could be in a collaborative task like grasping fruit, or maybe navigating, or just communicating. Okay, so today I will try to show you to do a class about how do we have to evaluate and our experimentation in human-robot interaction. So many people makes robotics that help people and interact with people, and when they present their results, they just present some quantitative metrics like the robustness, the precision, maybe the confusion matrix, but they do not evaluate how the acceptability of those methods are done by the volunteers or people interacting with the robots. So today I will try to show you how do we have to analyze our results and extract conclusions from them. Before I start with this class, let me show you some examples of what we are doing now. So I belong to the robotics, mobile robotics group. It means that I study how robots should move in different environments. They could be indoors and outdoors, public spaces, or crowded environments. So here the difficulty is that the robot should understand how people move and try to adapt its motion to these pedestrians. Okay, so it has to avoid obstacles, of course, but also has to follow the social conventions, respecting, for instance, the personal spaces. We work with in different tasks of navigation, like Alberto already explained to you, so I won't repeat it, but companion task, guiding task, and we work both with ground robots and also with the aerial robots. So let me show an example. Here we have a drone. So the idea of that work is that the robot could navigate close to a person, and we create a deep neural architecture where a robot understands and learns how people move and tries to adapt its motion to these pedestrians. Okay, in all that works that I am showing to you, we of course present our quantitative results. So we study the robustness of our works, but also we study how people perceive our robots. Okay, so we will study qualitatively how our methods and our frameworks are working on the real world. And the last part of part of my research, I will skip this slide, because it's more or less the same. It's about communication. So we saw that even if the robot is capable of interacting in some sense and avoid people on human spaces, we saw that we need to communicate with robots. You have to know that there exist two kinds of communication. The first one is the implicit one, like when you are walking on the street and you cross a person, there's an implicit communication that makes you decide if you will go on the right hand or left hand. Okay? This is implicit communication. And we work on that with the robot. This is not an easy endeavor, but we are having some results on it. But there's the explicit communication. I mean, we want to explicitly say something to the robots. Humans usually use 30% of verbal cues, 70% of non-verbal cues. The problem on our robot is that they work on outdoors. So in outdoors, it's very difficult because there are a lot of noise to understand what people want to say. That's why we start working on gestures. It means we want to have robots capable of understanding some hand gestures. And we do not stop here. We want to make an incremental learning. What does it mean? It means that the robot finds a new person, and that person wants to teach the robot a new gesture. The robot is capable of understanding and learning these new gestures. And this is called incremental learning. This is the robot that we are using. It's a Tiao robot from the PAL Robotics enterprise. And using this incremental learning, we are avoiding the catastrophic forgetting. This is something typical that happens in deep learning techniques, that when you learn new classes, in this case, the classes are gestures. So when you are learning new classes, you are forgetting the previous one. And using this incremental learning, we achieve two things. The first one is that we are avoiding the catastrophic forgetting. But on the other hand, we are capable of learning a new class with a few examples, with 20 examples more or less. So in an online mode, the robot can increment its learning and can increment the classes that he wants to classify. So let me show you some examples. Here I'm doing some gestures to the robot. We are using a well-known architecture called MediaPipe. MediaPipe gives us the landmarks on actually of the whole body, but we just use the hands. And with these landmarks, we create a new architecture that makes the robot capable of, on the one hand, classify the gestures, and on the other one, learn new gestures. I will show you an example of a video that I think it will be easier to understand. So here you can see that the system is classifying the different gestures. So it's detecting the hand and it's detecting the gestures. Those gestures are related to some actions. For instance, it could be stop, the robot, move, go backwards, go forwards. So here we are saying, okay, I will show you a new gesture. Okay, so here we are writing the name of the gesture, which means up, and then the system starts to capture new images. Okay, so after a while, the robot decides that he already knows that gesture and say, okay, I'm ready. So I don't need more information, so go ahead. So after computing all these samples, the model is trained with this new data, and here you can see that he knows the new gesture and says, okay, this is up, this is G7, G1, G2, and the system is capable of understanding new gestures. So why is it important to know how to make experimentation and evaluation on your interaction? Is because maybe you have a super cool algorithm that works really well, but when you apply this algorithm to volunteers, you see that they do not like this. They're not conform with the robot's behavior. Okay, so we need to evaluate how people perceive our systems and our algorithm. So today I will try, I think I won't have time, but I will try to talk about these three topics. So what is human-robot interaction? We will talk about some modalities and resources for social human-robot interaction, and we will finish with these evaluation methods and methodologies for this HRI research. So what is HRI? HRI basically is a field of robotics that systematically studies the interaction between humans and robots. So if you have a human and a robot doing something, you can evaluate this interaction. So we can find them on industries, maybe on streets like public spaces, or what are called the companion robots. Okay? So maybe the interaction here is explicitly or is implicitly. So in both cases, you should study how this interaction is performed. There are different levels of interaction. Okay? The first one is when humans and robots just coexist. It means that they share the working time and the workspace, nothing else. But if there's an aim that they share, then we say that the human and robot cooperate. And the most difficult one, which is when there's a physical contact between the robot and the human. In those cases, we said that we are studying the human-robot collaboration. Some examples, okay, to see, not because sometimes people has on its the mental model about human-robot interaction is like having a robot and a human talking, but there are other examples. For instance, this is a robot that helps blind people to walk. So here the communication is done basically with this stick. Okay, depending on what the robot sees, the robot will vibrate or not. So using this, the person can avoid obstacles, can also avoid stairs, or at least understand that there's a stair. And if there are other people on its way, also the robot can communicate with that person. So, but here the communication is done just using this stick. Okay? Another example. This is an exoskeleton made by Honda. So here the communication is done by contact. It means that the robot, this exoskeleton, needs to understand if the person wants to start moving, wants to start walking, or running, or standing up, or sitting down. So without talking, without any explicitly communication, they are interacting in some way. And finally, this is the Now robot. This Now robot is well used to help children with autism. So medical doctors here, what they do is they use this kind of robot as a channel of communication. So the children create an engagement with this robot and can communicate with it. And those robots helps those children to express better and to understand how they have to communicate and interact with other people. So here you see very different examples of this interaction, and for all of them, we have to evaluate how it's going. Okay, another example, this is a typical human robot. I guess that you all know it. This is Pepper. Pepper this is designed to interact with people. Okay, it's a human robot with wheels, so it can move, it can make gestures, it can make some manipulation with both arms. It has this robot is typical to have a screen here on the doors to communicate or express its intention. For instance, it has cameras. It can understand emotions. So it's a really complete robot. And regarding this, it's something that we cannot avoid, which is the appearance of the robot. Okay? In 1970, Dr. Mori created this graph that gives us a relationship between how a robot is human likeness and how the robot is accepted by people. So we saw that as more human likeness the robot is, acceptability of the robot increases. Okay, so maybe a robot like Pepper would be in this area. But we have to be careful because there's a peak, okay, which is called uncanny valley. So if the robot is too much similar to humans, usually humans don't like this kind of robot, and it means that they won't interact with a robot. So even if you have a super cool algorithm, you won't run it because pedestrians won't interact with the robot. Okay? And after a while, it increases again. Okay? But here we have to take into account that the culture also makes changes on that graph. Okay? For instance, here you see the Gemini robot. Those robots are very typical on Japan, and they are located in this area, so they really like this kind of robot. Nevertheless, on Europe, those robots are in this area, so people don't like this kind of robot. They don't want to collaborate with them. So be careful with the culture and people will interact with the robot. Okay. So now that we know what is an HRI, let's talk about the modalities and resources for this HRI. So the first thing that we have to talk is about the roles of interaction. It means which is the role of the person that will interact with the robot. Okay? So in that case, we have different roles. The first one is the supervisor. The supervisor is the person that needs to understand when a robot is having a problem, the seriousness of the problem, and the effect on the mission. Then we have the operator. The operator needs awareness of robot health, okay? Awareness of environment and awareness of what robot is doing to support the task or the mission. Okay? The supervisor and the operator could be the same person, okay? But it's not mandatory. Then we have the teammate. Here in that case, the robot is a member of the team. So here, teammates can give commands within the scope of the task. So here in an example, they are holding a table. But and here the interaction such as gestures and voice may be helpful here. But we have here we have a problem that maybe the cognition of the robot is different from humans. Maybe the robot do not understand all verbal cues. And so here we have to play with the mental model that the person will create with the robot. Let's move forward. Then we have the mechanic and the programmer. So it's the person who creates the robot and the person who makes all the algorithms. And finally, we have the bystanders. So the bystanders are people that has no formal training using that robots, but must coexist with it. For instance, robots and on the healthcare situation, floor cleaning robots, robot pets. So are people that find a new robot and has to interact with that robot, but those people don't have any previous formation. So here our challenges are that how can a bystander form a mental model of what robot capabilities are? That's why the appearance of the robot is so important here. Should a bystander have a subset of interactions available, or what type of social interactions come into play? So those things are the ones that we have to study when we have the bystanders. Some keywords to roles. So basically, one person might be able to assume a number of roles for a particular robot, as I said before. But the bystander only play the role of bystander, okay? Because if the supervisor makes the role of bystander and we are evaluating its behavior, we will have a bias problem. Okay? So all the volunteers that you pick, they have to. It's required to not have any previous participation on the project. So assuming that we can determine information interaction fleets for different roles, then we could use information to design a user interface to support the given role. Maybe we have to design different interfaces for the different roles. So maybe with the bystander, we use a verbal cues. Maybe for the operator, we use a screen where appear the errors of our code. And finally, we have to determine whether multiple robots could be supported in one user interface. And finally, some awareness. So awareness is frequently used in computer-supported cooperative work. Okay? And basically what it said is that given two participants, P1 and P2, who are collaborating via synchronous collaborative applications, awareness is the understanding that P1 has of the presence, identity, and activity of P2. But we cannot apply this to human-robot interaction because we have different, we have single or multiple humans interacting with a single or multiple robots, and we have non-symmetrical relationship between humans and robots. Until now, the cognitions of the robots are not the same as humans, so we are not in the same level. That's why researchers create its own definition of this human-robot interaction awareness, and says that it's understanding of the human, of their location, activities, status, and surroundings of robot. So the robot needs to understand what is allocated, which activities is doing, how is the status, internal status, and the surroundings of the robot. And the knowledge that the robot has of the human's command necessary to direct its activities and the constraints under which it must operate. So the robot should know that maybe we are giving an order that he cannot perform. Okay? So it has to understand its internal state and communicate what is happening to the volunteer. Okay, so basically, very fast, a general framework for HRI awareness. So HRI awareness consists of the 5 components: human-robot awareness, human-human awareness, robot-human awareness, robot-robot awareness, and humans overall mutual awareness. Okay? This is what we have to take into consideration when we are playing this HRI system. And the taxonomy. Why we need to classify the human-robot interaction? Because first, it's a way to measure properties of the system, and it's easier to compare systems. Usually when you do papers, I guess that some of you are doing research, so you have to write papers, you have to compare your systems with others, okay? If you have a humanoid robot performing a task, you cannot compare with other kind of robots. So it's necessary to classify not only the robot, but also the task that the robot is performing. Okay? That's an example. But I will give you a couple of an example just. So maybe we can define by robots and robotic devices like industrial robots or non-industrial robots. Here we have assistive robots and non-assistive robots. Here we have non-social assistive robots, assistive social robots, and then we have service robots or companion robots. So if you are working with a robot that is a companion robot, you can compare yourself with the existing works on that topic, but not, for instance, with industrial robots. So that's what it's all inside. Here you have another example, like here we are talking about the communication channel, the task of the robot, the reliability of the robot, the proximity, if they are touching or not. the form of interaction, like if it's collaborative, it's cooperative, or it just coexist. The application area, the morphology of the robot, blah, blah, blah. But it's necessary, it's very important to make your own taxonomy, to know where are your systems located. Okay. So most of you could think, okay, but human-computer interaction is a field that has more than 70 years. So why you don't just pick all the theory from HCI and apply to HRI? And that we cannot, okay? Because the tools metrics we cannot really transfer to human interaction, okay? Because we have the environment, and in the environment we have noise, we have maybe poor visibility. Robots has its own sensors, and sometimes the sensors fails, so we have to play with these sensor failures. Repeatability, it means if we have a robot performing the same task twice, it's probably that the robot won't behave by the same way, so we don't have the repeatability. And even more, if we have two different robots performing the same task, again, they won't perform the same task in the same way. So we don't have this repeatability that happens in HCI. Okay? That's why we need to create new theories and explain how to evaluate these HRI systems. Okay, so how do we evaluate our system? Okay. So HRI is a field of robotics that has about 3 years. And most studies cannot yet be reproduced. Why? Because if we have different robots and the hardware is different, we cannot compare how people behave with the different robots. So, like in psychology, it's difficult to agree on a methodology on how to carry out this research. Usually, what we do is we apply quantitative statistical methods requiring a large-scale experiments, for instance, involving large sample size of participants. This is almost mandatory, so you need to evaluate your system with a huge amount of volunteers, which it requires a lot of time. But on the other hand, we can pursue a qualitative approach, focusing on case studies and in-depth analysis. So you pick less people and you analyze how they are behaving. So what can we evaluate in HRI? So we can evaluate the behaviors. When I mean behaviors from the robot and behaviors from the volunteers. We can evaluate ways of interaction. If you have a specific robot performing a specific task, maybe you see that using gestures, it's enough, or maybe you have to combine gestures with verbal cues, or maybe you also need to add a touch screen on torso of the robot, depending on the task. Then there are social and psychological aspects that you should evaluate, and technical characteristics and objective measures like success rate, interaction time, error rates, if people want to repeat the experimentation or not. Okay, so that's I'm really very fast here, but regarding metrics, objective metrics, we can measure the task effectively. So how well a human robot team accomplished one specific task. So you tell the volunteer to perform a task, and you see if you observe if the team can achieve the goal or not. Then we have the neglect tolerance. Here is the autonomy for robots with respect to some tasks. So of course we want robots 100% autonomous, but it's very difficult to achieve this. So maybe we have to analyze which is autonomy of the robot. Then we have the robot attention demand. So how much a robot is demanding. It means, hey, the robot is lost on an outdoors. So the robot has to ask the person, where am I located? Can you help me? So we have to study this attention of demand. And finally, the fan out. This number of robots simultaneously operating. It's not easy. It's something that we also can remember. And then in 2009, there was a doctor who presented the US evaluation. And I will be very brief here, but basically they study the usability, the social acceptance, the user experience, and the social impact of this HRI system in the world. Okay? So indicators of usability. So we can measure the effectiveness, the efficiency, the learnability, so if it's predictability or not, the flexibility of our system, so if we change a little bit environment, the robot can adapt and can perform the task. The robustness, so this is the error preventing, responsive and stable, and the utility. Okay? And regarding the social acceptance, here basically we see the performance expectancy. So the humans, as I said, create a mental model of the capabilities of the robot, and we have to make sure that the mental model that the people created is the same than the robot can, that the real robot, that the actual robot. And then we have the effort expectancy and the aptitude using this new technology. Okay? So all these things have to be evaluated. Okay, so now that we know what we have to evaluate, let's see how we evaluate this system. Okay, so basically there are two parts. The first one is the study design. It's what I want to analyze. So here we have to define the research questions, see the methods, and the evaluation of the results. And the second part is, okay, now that I know what I want to evaluate and what I want to answer and which are my hypotheses, and usually we use some questionnaires. Okay? So you have two options. The first one is to use an existing questionnaire that I will show you. I will give you an example that you can use, or you can create your own questionnaires. The point is that if you create your own questionnaires, you have to validate and you have to demonstrate the validity and the reliability of those questions. Okay? If not, you cannot use your own question. Okay? And this is the second part of this section. So regarding the study design, so we have to define a testable question. Okay, so it is what we want to demonstrate on our experimentation. So here the wording is crucial. So difference question, relationship question, determine the method analysis. So, and then we have a variable. Variables are those factors or conditions that can exist in different amount type of your research study. We will see an example now, and I think it's gonna be easier to understand. So here, what do I want to demonstrate? And that's why we have to define what is called the research hypothesis, which is a statement which speculates the outcomes of the research experiment. What do you expect is the answer to the research question. This is the hypothesis. Okay, so imagine we have the null hypothesis, okay, which is something that we want to reject, and we have the alternative hypothesis. The alternative hypothesis is the point, it's the thing that I want to accept, to demonstrate. And the only way to accept my alternative hypothesis is rejecting the null hypothesis. Okay, for instance, imagine that I have a robot and I want to demonstrate that a more intelligent robot will be more sociable, accepted than a less intelligent robot. Which will be the null hypothesis: a more intelligent robot will be equal socially accepted than a less intelligent robot. This is the one that I want to reject. Okay? So here, and then we have the p-value. Okay? The p-value is the level of statistical significance and is often expressed as a value between 0 and 1. In human-robot interaction, usually we said that if our p-value is lower than 5%, it is 5.05, it means that I statistically reject my null hypothesis and therefore accept my alternative hypothesis. Okay? So now we know our research question. So it's something I want to demonstrate with my experimentation. We have the null hypothesis and the alternative hypothesis and the p-values. And then we have the variables. The variables that are the ones that you control and that you play with. Okay? So here we have independent variables and dependent variables. Independent variables are the study factors and conditions. So are variables that you control, okay? Variables that are manipulated for the study. And they are not being affected by other variables. On the other case, we have the dependent variables, which are the study outcomes, the measurements. Okay? And they are affected being studied, and they're influenced by other variables. Okay? So those are the different. The independent variables are the ones that I control for my study, And the dependent variables are the ones that I do not have any control. I have to observe what is happening. That's an example. Imagine I have some companion robots that help elderly people. Okay? So my independent variables are the use or not use of this companion robot. So I have two groups. The one is use a pet robot as a companion robot for elderly people. Group B, don't use a pet robot as a companion robot for elderly people. So my independent variable is the use or not use of this robot. And which are the dependent variables are the participant response. This participant response will give me some results that I have to analyze, and they will be and it will give me the opportunity to reject or not the null hypothesis. Okay. So the research question determines the study variable. So more or less is you have your robot, you will design your experimentation, then you decide what you want to analyze, which is the research question, and after that you determine the study variables. Okay. So the methods. So here we see for the methods, the elements of a study are the procedure, the participants, and the measurements. So who will make the experiments, how we perform the experiments, and what we will measure. Regarding the procedure, basically, you have to define how will the study be conducted. Okay? What are the steps of the study? And what instructions will you give to the participant? Okay? What does the robot do and when? And how does the robot react to humans? So basically, you have to decide all the steps of your experimentation setup. Okay? Or in that video, you see a robot that is interacting in a public space, in a medical center. Then the researchers decide that they will work in this open area, and the robot work in that lobby. So and the robot is capable of interacting with people. So here they want to test the social proof. So use. So it could be neutral, just saying hello, going forward, whatever. Okay, but they decide all the capabilities of the robot. Okay, they use an example of when it's neutral, so it's doing nothing. If the robot says hello, blah blah blah. Okay? The point here is that you have to decide also where and when is the study conducted. Okay, how many days, in which area, during the day, during the night, how many hours. Okay, the participants. So you have to look for participants that are representative of the person that you want to interact with the robot. For instance, if you work with children with autism, you have to make experimentation with children with autism. Okay? Don't elderly people. Okay? Then you have to decide the number of people needed for validity. Usually, I would recommend around 20, 30 people. I know that it's difficult sometimes, but with less people, you will have a bias problem. And to recognize limitation of your sample, so you have to describe all the limitations. Here, we are aware of response bias, so shared trait of volunteers influence as study variables. If you want to make a good experimentation, you cannot test the system with yourself or your colleagues. Okay, it has to be people from outside the lab. And the sample bias, so participant selectors are not representative of the population. Of course, I will skip this part, but take into consideration that you require the participant consent. You have to ask them if you can record videos or not, okay, blah, 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 blah. And the participant instructions. You need to give the same instructions to every participant. It means that my recommendation is that you write down in a paper and you give the paper to everybody just to give the same information to the user. Or maybe the robot can express the instructions of the experiment, which is even better. And measurement. What do I want to measure? Okay. So the data that we collect could be qualitative or quantitative. Okay. And in both cases, we need to study. And depends of the kind of data that we have, we will use some statistical tests or others. Okay. So usually for qualitative data, okay? We collect this data using observations, so you are there and taking notes, interviews with the participants, and open-end survey questions. We can use to provide quotes, case studies, coded into quantitative data. Okay, so just some examples. The open-end questionnaire. The open-ended questionnaires, here the respondent can answer in a free form with little to no restrictions, and allow the respondent to voice their feeling, like tell me about, what do you think that the robot is behaving in that way? How did you find interaction with the robot? Whatever you want. Okay? And can be answered in depth and allow original and new questions. Many produce unexpected results. So this kind of surveys give us a lot of information, but it's very difficult to translate it into quantitative data. So we cannot manage with this with the statistical test. Okay. So I recommend to use this qualitative data, of course, because it gives you a lot of information. But be careful with that, because you cannot make some mathematics there, and you cannot play with this data. Okay. Then we have a subtype of these open-end questions. So, for instance, questions that are prepared to give respondent opinion with a limited set of words. What do you think of the horrible effects of pollution? Here we are playing with the volunteers, because we are leading them, and we would have a bias problem here. So I would skip this kind of question. And then we have the closed-end questionnaire, that here it's easier to translate into math. Okay, because we have multiple choice within scales, then we can translate to a numbers, and then we can play. So my advice is to maybe in your questionnaires, if you want to create your own questionnaires, play with different type of questions, like the open end and the closed end, because both of them give you different information that can help you to extract and to demonstrate your hypothesis. Okay, I will skip this part. And why do we have to use these questionnaires? Remember, using those questions do not mean that you don't have to make all the analysis of your algorithm. Okay, so the first part is demonstrate the robustness of your system. You have to demonstrate the accuracy of your system, the robustness of your system. But after that, when you have an algorithm that is working, or a robot that is working probably well, or you think that it's working probably well, you have to go one step further, analyze using these questionnaires, the acceptability, or whatever you want to demonstrate of your system. Okay? So some advantages of the questionnaires: they are very cheap, okay? They are very practical, they are fast, they are scalable, we can compare different questionnaires, it's easier, an analysis is very easy, and the responding, it's anonymity response. Okay? And the coverture. Okay? I would recommend not use more than 10 questions, and each questionnaire has to be solved in no more than 5 minutes. Okay? If not, people get bored and they ignore the question. Okay? Some disadvantages. We can have dishonest answers. We saw that maybe the participant wants to answer what they believe that the researchers expect from them. So we don't have these honest questions. We can have unanswered questions, misunderstanding of the questions, hard to convey feelings. They are difficult to analyze sometimes, and inconsistent response. Okay, and we have what I said, the questionnaire fatigue. If the questionnaire is very long, people just will answer randomly. Okay, so just some advices. Figure out what information do you want to extract. Okay, keep your questions simple, clear, data, and consistent, and use words with clear meaning. Okay, use only words or two answers method, like scared and fill in blanks, and just 5 minutes of preparation. Okay, this is for qualitative data that we extract from the questionnaires in this sense. Okay, but it's important for demonstrating this statistical significance to have numbers to play with math. Okay, and here there are many types of questions that we can do in our surveys. Usually people use this semantic differential. For instance, the color blue makes me feel sad, so we have multiple options with the different feelings. Or the color blue makes me feel, and then you have sad, happily, and then. But as you may see, it's very easy to convert the choices into numbers. Which is what we are looking for. Okay. Here, again, it happens that we can have the social disability bias. So people try to act in ways that we expect them to act. And then confirmation bias, researchers with an hypothesis evidence supporting the hypothesis more clear. Okay, so we have to try to avoid this aspect. Here I'm giving you some advices of if you want to write your own questions, and I'm giving you the Godspeak survey. There are many others, but this is the most famous and the most used in the research area. It's a questionnaire with a lot of questions regarding different topics when you are doing HRI. So you can pick some of parts of these questions, or maybe some of them. And in your papers, if you write down that you are using these questionnaires, it's the reviewers will accept this. Okay? So don't worry with that. Here you can see the different, what I said. It's yeah, this can measure the anthropomorphism on the robot or the animacy. You can check. You have the link here, and you can just see how this is working. Okay, so now that we know what we want to analyze, which methods can we use? Let's see how do we obtain the results. So you know that there exists different type of data. Okay, we have the categorical data, ordinal data, the numerical one. It could be interval, ratio. Okay, I won't go in deep because you already know it. But depending on the type of the data, we will use some statisticals or others. Okay, so my goal now is to give you some recipes that tell you which have to use, which test you have to use depending on the data that you have. Okay, so okay, I will skip this. It's not important. So imagine that we have our hypothesis is that a more intelligent robot will find the fastest way out of the maze. Then the null hypothesis, which is the hypothesis that I want to reject, is just the opposite. A more intelligent robot will find the same way out of the maze than a less intelligent robot. Okay? So if I have a p-value, that this p-value will be the statistical test will give me this p-value. So if the value is lower than 5%, it means that I can reject the null hypothesis and then accept my hypothesis. Attention, if you have a p-value of over 5%, it doesn't mean that you have to accept the null hypothesis. It means that you cannot reject the null hypothesis. Okay, be careful with that because it's not the same. Okay? So to know which test we have to use, you have to ask yourself, do you have a differential relationship questions? How many independent variables are you testing? What type of data is independent variable? How many dependent variables are you testing? Usually we have one. What type of data is the dependent variable? Is my data normally distributed? This is crucial, okay? Because some tests have as a requirement that the data is normally distributed, and then people apply this method, and they are not well applied because the data is not normally distributed. Okay, so let's see some examples. Okay, if your dependent variable, so the variable that you cannot control, it's categorical, you likely want to use the chi-square test. So here we have independent variables with 2 or more groups, dependent variables with categorical data, and test whether a frequency of observed values is good. Okay, so I want to show you that it's super easy to use these methods, and I prepared a code on Python. So I will stop sharing here, and I will share another screen. Just give me a minute. Okay. Wait a minute, it does not allow me to show you my screen.
No, we cannot see.
Yeah, I know. Because give me 1 second, please. Okay, I see that I cannot show you my whole screen. But Anna, once you upload all the presentations, can I give you some code to share with the students?
Yes, I will try to share with them. Yeah.
Because I think it's good to have some examples, and I will share the code with you, and I think it's gonna be easy because now I don't know why I cannot share my whole screen. That's the last slide. No, I cannot. Okay, so I will move on.
Anaís, you send it to me by mail or what?
No, don't worry. I will send you when we finish this session.
Okay.
Because I prepare some code for you. Now you see my presentation right now, right? Okay. So yeah. I prepare some code for you, and you can see how the chi-square test works. Also, how if you want to use the magnetic test. So I will share with you different tests and different codes, and you see that using Python, it's very, very easy. Okay. Another example of this test: if your dependent variable is measured using this interval ratio, here you can use the t-test. Okay. But here you have independent variables with two groups, and the dependent variable, it has to be normally distributed. Okay. If it's not normally distributed, you cannot use the t-test. Okay. And ANOVA is this a particular example where you have more than two groups. Okay. Here in the t-test you have just two groups, and with the ANOVA you have more than two groups. So I will show you, I will share with you this Python code. But how do we know that our data is normally distributed? Using another test, which is the Mann-Whitney-Wilkinson test that will tell us if our data is normally distributed or not. If it's not, we cannot use the t-test nor the ANOVA. If it is, you are free to use that. Okay. Okay. So with that, you know, more or less, you know how to obtain the data. You know now how to analyze the data. So depending on the data that we have, if it's categorical, it's not the number of groups, if it's normally distributed or not, you will use different statistical tests, and you can demonstrate, you can reject or not your hypothesis. Okay? The second part talks about how do you create your questionnaires. Okay? Imagine that the existing ones do not fit with your problem. So you create your own questionnaire. So here, once you have your questionnaire created, you have to demonstrate the validity and the reliability of your questionnaire. So I will skip this because I just have 10 minutes and you can read it after. But the concept of validity is, it means it's the ability of an instrument to measure what is intended to measure. Maybe you are measuring the acceptability of the robot, but after doing this analysis, you are not analyzing that. Okay? So you created the questionnaire in a wrong way. That's why it's so important to demonstrate the validity. Then degree to which the researchers has measured what has to set out to measure. Okay? So there are many methods, okay? many methods. The first one is the average congruency percentage. It's very easy. You need to have a panel of experts on HRI, okay? And give the questionnaire to those experts. Okay? So if they agree 90%, it means that the questionnaire is valid. If not, it means it's not valid. Okay? For instance, we have one expert that give us a 100% of validity. So all the questions are okay. But the second one, it gives us an 80%. So the mean is 90%. It means that it's basically it's valid. Okay. Another one, the content validity index. Here we have two, the ICVI and the SCVI. I prepared an example. I think it's gonna be easier to understand with an example. Basically, the ICVI you give the questionnaire to the panel of experts, and they evaluate using a 4-point like. So it means 1 means not relevant, 2 somewhat relevant, 3 relevant, 4 very relevant. Okay. Then you split the results into 2 categories: relevant for 3 and 4, and non-relevant for 1 and 4. And the proportion is computed. So if 4 or 5 experts give a score of 3 or 4, the ICV is an 80%. Okay. And the universal, it means universal agreement. Okay. All the content experts has to agree with this. Okay. So we can measure the universal agreement and the average. Let's see an example, which is very easy. You have a questionnaire with 10 questions, and you have 6 experts, and those experts say if that question is relevant or not. Okay? For instance, for the first one, we saw that we have a number of agreement in 5, so the item CPI is 80%, and for instance, 7, 8, 9, 10, it's 100% of agreement, and you have all these measures. Okay? So this is the way that you evaluate your questionnaires. You have to pick for 5, 6 experts on the topic. Here I'm giving you a scheme that it's very easy to understand. So which one do you have to follow? Depends on you. Okay. My recommendations are as follows: report both the values ICVI and SCVI rather than using the CVI as an acronym. Report the range of ICVI values, and the best method is SCVI universal for stringent validity, but will be difficult to use if multiple experts are validated. So in such a situation, you can use the average. Okay, and reliability, the last part. This is the ability of an instrument to create reproducible results. Okay, so it means that the results that you obtain from your questionnaires are not altered randomly. Okay, it has some consistency. Okay, and here we have to measure the stability, okay, the internal consistency, and equivalence. You will be that it's very easy. For stability, it's done to ensure the same results are obtained when used consecutively or 2 or more times. Okay, here we use the TRES method. Okay, so the idea is that you give the survey to the participant twice, okay, in different times, and you have to analyze how it varies along the time. Okay, what we want is something with the TRES accordation formula. So we want something close to 1, okay, because it means that we have this reliability on our system. Then we have the internal consistency. This is crucial. Okay, this is crucial. This is, imagine that you have some parts. One part evaluates the acceptability of the robot. So you have to evaluate if all the questions regarding to this acceptability are in concordance. Okay, and it's called the split half method. Okay. Very easy. With that method, what you obtain is the Cronbach alpha. This alpha tells us the consistency of the question. Okay? Usually, you may say in the papers, when researchers publish its surveys, they publish the questions and the Cronbach alpha of each subpart. Okay, this is important because it gives us the opportunity to know if you have this consistency or not. What happens if you have a consistency lower than, for instance, 0.7? It means that one of the questions are not related to that topic. So you have to discover which question you have to remove. And when you get this value of alpha will increase. Here I'm giving you the code to compute this Cronbach alpha. Here you have an example of different parts of a question. For instance, the first one has a perception of ease of use, and we have 5 questions, and this is reliability. Then another perception of usefulness, we have 5 questions, this is reliability. So you see, for each part of the questionnaire, we have a different number of questions, and we compute this Cronbach alpha. And finally, the equivalence. Used when 2 observers study a single phenomenon in simultaneous. So basically, we have this R, which is number of agreement divided by number of agreement plus number of disagreements. So we have 2 users, Mark and Susan, and we are asking something, and we analyze the disagreement of this. Okay, this part is not so important, but with the one that I really highly recommend you is the second one. Okay, so I'm giving you just a resume of what I explained, and just create a questionnaire. We reduce the bias and ambiguities, and we have a better quality of data on credible information. So in a nutshell, a questionnaire can be relevant but invalid, but a valid questionnaire is always relevant. Okay? And with that, I finish my talk. I think I am on time.
Yes, you are on time. You are on time. Thank you very much, Anaís.
So I'd be happy if there's any question. Thanks, Bruno. I think, or it has been very clear, or nobody understood anything.
Okay. Okay, Anaís.
It was clear. Thank you, Anna.
Thank you very much for your
Anna,
presentation.
I will send you the code just to give them the opportunity to play with it and all the statistics.
Okay.
You use Minitab too? No, I'm not using Minitab, Ivan. We create our questionnaires, we analyze them basically we use Python, and it's very easy.
Okay. We leave it here.
Okay, thank you very much.
Thank you.